Hello everyone and welcome to another programming video. In this video, we are going to solve the Leetcode problem called 2sum2. This is very similar to 2sum problem. So in this problem, we have been given an array of integers and the problem specifies that the array is one index where the index values start with 1, 2 going up till n. This array is sorted in non-decreasing order. All it means is that the elements are not in decreasing order. So in this case, for example, the numbers here are not in decreasing order. But we could also have an array like 2, 7, 11 and 11 and 15 and it would still be valid input. So we need to find two numbers such that they add up to the specific target number. So this is very similar to 2sum. First difference here is that the array is sorted in non-decreasing order, and once we find the two numbers, we need to return the indices of the two numbers, but we need to add 1 to each of the index value. For example, for the array here, the target value is 9. The numbers which add up to 9 are 2 and 7 at index 0 and 1, but we need to return one index value. So we'll have to return 1 and 2. It says here that your solution must use only constant extra space. This means that we cannot use another structure like a hash map, for example, which grows with the size of the array. So here we are with our input array nums, and for ease of understanding, I'm going to stick with 0 index values, and then when we return the answer, we will add 1 to the index values to make it 1 indexed values. Right. So our target here is 27. And we need to find two numbers which add up to 27. Now a brute force approach might be we start at this index 0 and we check the remaining array. If there's a number which when added to this 2 gives us 27. So in this case we are searching for 25, and because it doesn't exist, we can then go to the next number at index 1, which is 7, and in this case we need to search for the number 20 because 20 plus 7 gives us 27 in the rest of this array. Now this process will eventually find the two numbers, but it is quite slow and its complexity is O of n squared. That's because for every index value we are checking the remaining array elements to find the number which adds up to the target. But note that we have been asked that we can only use constant extra space. So that essentially rules out using another structure such as the hash map, which we can use in problems like the 2sum. Since we want to find two numbers, we definitely can use some form of two-pointer approach here, right? Because we still want to find those two numbers which will be at different indices. Let's say those two pointers were I and j here, okay? We would need to initialize them to certain positions such that we can then iterate through this array and find those two numbers which add up to the target. So one of the patterns which is quite common when you have a sorted array like this and you can't use any extra space is to position the two pointers at the start and the end of this array. And now we can try to add the values at these two index elements, right? So if we add up nums of I and nums of j, we will get 17 because 2 plus 15 is 17. Now we notice that 17 is less than 27. Okay, so what does this tell us? That means that we need to add a bigger number than we added. So out of 2 and 15, right? So 2 and 15, 1 needs to be bigger. So because the total is now less than 27, we are falling short of 10. So one of these two numbers has to be bigger, has to be higher. We can't obviously find a higher number beyond this because that's the end of this array. But we can look on our right here and we can find a bigger number. So if I increment I to the next index element and j stays where it was, and now try to add the two together, I'm getting 7 plus 15 equal to 22, right? So now if I compare 22 and 27, 22 is still less than 27, which means I'm still falling short, which means I still need to find a larger number. Now we can see here that again we can't find a larger number beyond this point, but we can definitely find a larger number beyond this point. So what if I increment I by another position? Now my pointer I is at index 2. And now if I add 11 plus 15, I get 27, which is equal to our target, right? So we managed to find the two values which add up to the target. And when we return the indices, we don't want to return just 2 and 3. We want to add 1 to each of them, because the problem statement says that it's a 1 indexed array. So we'll return 2 plus 1, which is 3, and 3 plus 1, which is 4. So this will be our answer to this problem. Okay, so as discussed, we will define a loop, and in this loop we will have two pointers. The first pointer I will start at index 0. The second pointer j will start at index n-1, and we'll do the calculation in a while loop. So we'll run the loop till I is less than j, and inside the loop we'll calculate the sum of the values at these two indices. Now if the sum is equal to our target, that means we have found the numbers we were looking for, and we need to simply return their indices, but we need to convert them to 1 index values. If the sum is less than target, that means we need a larger number, and since I is going from 0 to n and the array is in kind of increasing order, we can find a larger number by incrementing I. Or if sum is greater than target, which means we need a smaller number, by decrementing j we can get to a smaller number, again because the numbers are in non-decreasing order. If you look at the problem statement, it says that the tests are generated such that there is exactly one solution. So which means that we don't have to worry about what if we don't find the two numbers in this loop. We are guaranteed that it will be found. So in this case, I am simply going to return null if I haven't found those two elements in the array after the while loop. An alternative is to throw an exception. Thank you very much for watching. I hope you found this video useful. If you have any questions, please do post them in the comment section on YouTube, and please do remember to like and subscribe. Thank you. Bye.